Good morning, everyone, to this special seminar on sustainable energy development. Honorable Ambassador, honorable keynote speakers, respected Icelanders, foreign residents, dear colleagues, dear students, ladies and gentlemen. It's my pleasure to welcome you to this second seminar on sustainable energy development. This is a joint initiative between Reykjavik University, located in Iceland, and the Energy Institute at the Johannes Kepler University in Linz, Austria. The reason why we have this collaboration is that there are some similarities between those two locations. Reykjavik University is located in Iceland, and Iceland has put forward an ambitious climate action plan to become climate neutral by 2040. Furthermore, in Iceland, a big chunk of the greenhouse gas emissions come from the heavy industries. The decarbonization of the industry is a big challenge to reach these climate goals. Vice versa, in Linz, Austria, is the energy center of Austria. The heavy industry is located in Austria, in Linz, with the steel production, and the Austrian government has put forward an ambitious climate action plan to decarbonize the energy sector and become entirely dependent on renewable energies by 2030, which is in 7 years. So these challenges require collaboration between industries, academics, and of course also stakeholders, students, and politics. Yesterday, we had an innovative seminar focusing on ongoing projects in Austria with contributions on climate neutral gas, like biomethane, synthetic natural gas, and renewable hydrogen, industrial symbiosis, plastics in a circular economy, green hydrogen, and sustainable energy development in Africa. Today, we have a further program, and it's my pleasure to introduce the Ambassador of the European Union, Lucie Samcová, and we will then have contributions on the EU energy communities, energy cooperation in Iceland, energy developments in the Balkans, and an overview of the H2 COP storage project, and energy cooperation in Belgium. And finally, we will conclude with the Austrian citizen cooperative from Austria. So I would like to ask the audience to please write your questions into the Zoom meeting chat, so that we can address the questions after the conference, or perhaps switching between the different speakers. So with this, I would like to ask the first speaker. It's my pleasure to introduce the Ambassador of the European Union to Iceland, Lucie Samcová. If you could share your slide, and the floor is yours.
With pleasure. Good morning, everybody. Good morning to everyone who's joining us online today. And thank you, David, for having me. I'm very excited to be a part of this event. I saw that you already had a very full day of presentations yesterday. I saw some of it online late last night, and I'm also intrigued by some of the themes that you will be discussing later today. I do not have slides to share, but I hope that I can hold everybody's attention for maybe 5 or 10 minutes, even without visual aids. I was going to pick up on some of the themes that you mentioned, David, in your introduction. So, where are we when it comes to the EU and Iceland energy cooperation? I can clearly say that the EU and Iceland are very close partners in the realm of energy for several reasons. It's not only because Iceland, as you know, by virtue of being a member of the European Economic Area, has transposed and applied some of the relevant EU legislation, but also, and I think this is even more important, because there is a very close affinity between our mutual ambition and objectives in this area. The EU, just like Iceland, is focusing on what we call changing up our energy sectors and making them more sustainable. The production and use of energy accounts for more than 75% of the EU's greenhouse gas emissions. And this is why decarbonizing the EU's energy systems is critical if we are to reach our objective before 2030 and fulfill our long-term strategy to combat climate change. In 2020, as you probably know, the EU launched the European Green Deal initiative, and the ultimate goal of that initiative is for the EU to become a climate neutral continent by the year 2050. So here you can see already a very close rapprochement, a very close affinity between what we want and between what you referred to already on the side of Iceland. Just going back to the Green Deal strategy, it's quite a vast policy paper, so I'll just refer to a few things. The goals of the Green Deal also include no net emissions of greenhouse gases by 2050, economic growth that is decoupled from the use of resources, and prioritizing energy efficiency, improving the energy performance of buildings, and developing a power sector which is based largely on renewable resources. I want to, in the few minutes that I have this morning, touch upon three themes, three keywords, which I believe are essential and which can get us to a climate neutral Europe. I will be talking about purpose, about investment, and about collaboration. So the first one, purpose. To reach climate neutrality by 2050 and a reduction of at least 55% of the emissions already within the next decade, we need to act with purpose. We need drive, and we need to focus our efforts on clean energy research and innovation. We need to look ahead at the long-term challenges and changes in energy and how they can positively contribute to fighting climate change. The EU has success stories already in terms of energy from the last few years. I'll just give you a few examples. For instance, the share of renewables in the gross final energy consumption doubled from 2004 to 2019 and is now making up to 20% of the EU's energy consumption, which of course, compared to Iceland, is not nearly as significant, but Iceland is in a very privileged situation for several reasons. Other good example is that the costs of lithium-ion battery packs for electric vehicles has fallen by 89% in the last decade, which again makes it much more easier for consumers to go in this direction. So this is the direction of travel that you want to go in. Iceland, as you already mentioned, and as you've been discussing yesterday, has achieved some fantastic feats in becoming a more environmentally friendly country. And of course, Iceland's ability to harness geothermal energy is commendable and something of a luxury in the energy world. Because about 85% of the total primary energy in Iceland is derived from domestically produced renewables. That being said, on both sides, both in the EU and in Iceland, I believe that we can and need to do more. And this also came across very clearly in the message of the Prime Minister, Katrín Jakobsdóttir, at COP26, where she spoke just a few weeks ago. The second keyword that I want to talk about is investment. In terms of investment, the EU is a driver in new green technologies. We assume that almost half of the CO2 emissions reductions that are needed by 2050 will come from technologies which are in development and perhaps not yet on the market. We are constantly seeking for new creative ways to help our move away from fossil fuels. And Iceland comes very strong in this department. The EU's Horizon 2020 research program, which perhaps you're familiar with, has supported multiple Icelandic projects in this area in the past. One of the projects that we consider a great success is Carbfix, which is quite a revolutionary way of turning CO2, oversimplifying, into stone and injecting it underground. The project received a 600 million krona funding from the EU in its early stages, and it's one of those projects that we look at with great hope for the future. But there are others, perhaps smaller in scale, but just as innovative and just as ambitious in Iceland, which are receiving EU support as well. This was Horizon 2020, a program which ran up to the year 2020. This year, we launched a new program, which is called Horizon Europe, again, focused on research and innovation. It will run for a period of 7 years until 2027. And we are proud to announce that the funding of the new Horizon Europe has doubled compared to the previous iteration. And it has a massive budget of 95.5 billion euros. And a lot of this will be in support of innovative energy solutions. So our hope is that Horizon Europe will support once again in Iceland a multitude of applicants and allow us collectively to make greater technological leaps. The third and final keyword that I want to speak about is cooperation. The EU recognizes very clearly the importance of cooperation in changing up our energy sectors. We believe that we can accelerate the development of clean energy solutions only through effective collaboration. A good example of the EU's interest in collaboration is projects of common interest, PCIs. And these are cross-border infrastructure projects within the EU, which connect energy systems between the different member states. And the EU then helps countries in priority corridors and in priority thematic areas to work together to develop better connected energy networks and provide funding for new energy infrastructure. So in conclusion, because I am only here to open the day and the bulk of the work and presentation is still before us, I just wanted to say that the EU and Iceland are heading very much in the same direction, that we want to develop new and green ways of producing energy while growing our economies at the same time. And we believe that the two are not mutually exclusive. We are both participating in achieving the goals which we have set for ourselves in the Paris Agreement. Our goal ultimately is climate neutrality, and I believe that with these principles in mind, we will get there together. Thank you.
Thank you very much, Ambassador Lucie Samcová. I think we can give the ambassador a big applause for her introducing talk. We have time for a very short question. Meanwhile, I would like to ask Lionel to prepare his slides and share his slides. So anyone who would like to take the opportunity to ask the Ambassador of the European Union, please feel free to do so now. Okay, if there's no question, I might ask a question as an academic from the university. What would you see the best tool that the European Union provides to universities to continue the collaboration like we have with Erasmus+, we have, of course, the Horizon projects. What would you tell young students that are studying currently at the universities, how they can become part of this huge challenge and also this huge opportunity to bring in their ideas and innovation and energy into the challenge?
Thank you for this question. I think Iceland is already doing it exceptionally well. And I should point out that when we look at the quality of the applications and the projects which Icelandic research institutions and others are putting forward for EU funds, they are extremely good. This means that Iceland is actually more successful. The average success rate of applications under the EU research program is about 10%. For the case of Icelandic applicants, it's 14%, so you are above average. I think that your researchers and your institutions have proven over the years to be also partners very much in demand by others. So all I would really say is you are on an extremely good trajectory. If I'm talking to young people who are interested in getting more involved, the opportunities are there. Don't hesitate to take them, put yourselves out there, network as much as you can, reach out to partners also outside of the EEA, because I think that perhaps one of the not limiting factors, but there is always a very close affinity of the Nordic region and a very close cooperation within the Nordics and within the EEA But don't hesitate to also look further, look beyond Europe, because we need good energy solutions not only in Europe but also very much globally. And we know now that in fact European emissions only account for about 7% of global emissions. 93 are emitted elsewhere, so we need to work with other big polluting countries to make a difference. So that would be my advice.
Thank you very much, Ambassador. I think this is a strong message to all the young engineers that we have in the audience. And it's made perhaps also a nice message for our Professor Daniel Egbe who was giving a talk yesterday about energy developments in Africa. So the EU is open also to collaborate.
Maybe I will just, I want to congratulate the ambassador. And I'm happy that you mentioned this aspect of global collaboration, because to mitigate the climate issue, we need international collaboration, not just limited within Europe. And I know the European Commission have allocated just around 350 million euro within this Horizon Europe for Africa, which is, and for just 40 projects, which I think is not much, but still, and I appreciate it. But I hope that the cooperation between Europe and its largest neighboring continent, Africa, should intensify to address this climate change issue. So I think more will be done, and I hope researchers from Iceland will also turn towards Africa. I thank David, who is already doing something in the direction, and I think the University of Reykjavik is cooperating with some few African countries from Kenya, and that's what I've learned of recent. And I hope this cooperation would intensify. We need a global solution for global problems and global cooperation in research. Thank you.
Thank you, Daniel. Thank you again, Ambassador, for joining us. And we will proceed now with the first presentation. Lionel Delchambre will represent coordination of REScoop.eu. And please, Lionel, feel free to share your slides.
Yeah, thank you, David. To everybody, can you see my slide? Normally, you should see the screen.
Yes, I can see it, yes.
Yeah, okay, thank you. Good morning, everybody. Thank you, David, for giving us the opportunity to present this citizen energy movement. This presentation is about the European citizen movement, and we asked an official representative of REScoop Europe to present today, but it was not possible. So I will try to take this role and to explain the best I can. So this presentation is on two times. The first part is about presenting the movement, and the second part is about the more regulatory work that is occurring now on the transposition of the two directives, the Renewable Energy Directive 2 and the Internal Electricity Market Design. But first of all, okay, what is REScoop Europe? What are we presenting? REScoop Europe is a federation of the citizen energy cooperative across Europe. Basically, it gathers almost 2,000 REScoop. A REScoop is a citizen energy cooperative complying with some principles, and I will present those principles later. But basically, those are European citizen cooperative gathered in a federation. And this represents more than 1 million citizens in Europe. So this is a huge movement. Currently, the federation can employ 13%, and it's directed with, by a board of 8 cooperatives. And those cooperatives, they are elected among the 1,900 REScoops. So REScoop Europe is a federation of the citizen energy cooperatives. And what is doing REScoop Europe? They are doing a lot of different activity, but mainly they are performing some advocacy work. So they are working at the European level to make recognize the citizen energy movement, to orient the regulatory framework. So this is really the lobbying part. They are also setting up some funding to support the citizen movement at the local level. So some financing. They support the movement by developing the network. So they ensure the collaboration between the citizen cooperative at local level. So it's really about how can you empower citizen energy communities by making them collaborate. They share the good practices. Sometimes they are developing new services and they broadcast, they disseminate the result of those services, or they just share the tools developed under some project. So advocacy, funding, networking, and service broadcasting. This is the main task of REScoop Europe. So I said REScoop Europe is a federation of citizen energy cooperative, but what is a citizen energy cooperative? I think it's important to take time to really understand what is it. So basically, a citizen energy cooperative is a private company owned by citizens. So you can imagine a project where there is a wind turbine, for instance, because in Belgium, the citizen energy cooperative movement really starts with this kind of project. So citizens in a city want to develop and to own a wind turbine park. So they gather together and they build a private company, a private cooperative, in order to achieve those activities. And so this is a private company owned by citizens, and it is complying with 7 rules, 7 principles that are the 7 principles of the International Cooperative Alliance that are here stated here. So the first principle, the idea is the energy cooperative should be open to all the members. It's really important. You cannot discriminate a class of members. It should really be open for all the people who want to join the movement. The second principle is about the participation. It's really important that the energy cooperative is owned by the local stakeholders. So I've talked about the citizen. It's also open to local public authorities or to local SMEs. And it's important for them to own the energy cooperative by an economic participation. It means that the citizen, the public authorities, the SMEs own a share of the energy cooperative. Basically, this means that they are the shareholders of the private company. And this is important also. The economic share, like the share, it can vary between 10 euros to 500 euros. It really depends on the specificity and the locality of the energy cooperative, but it depends. The third principle is about democratic ownership. It's really important that the citizen can decide, the citizen and other stakeholders can decide in this energy cooperative. And so it's important to embed in the status of the cooperative some democratic principle. Usually we are talking about one member, one voice. And so it's really different from the classical private company, because usually more you have shares, more you have power within the private company. Here it's different. It's also really important for the energy cooperative to be autonomous and independent, for instance, from the other big energy companies such as Total, such as Engie. So it cannot be linked with this kind of company. It's really totally autonomous. Also from the public body, it's really important to ensure that the citizen energy cooperative is independent, even if the public authority can buy and own some share of the citizen of the cooperative. The 5th principle is also important. The idea is, okay, this is a private company, so it will make some profit and it can distribute benefits, but it's important that part of the benefits of the company are oriented towards training and education. This is really an important principle that sometimes it's forgotten, but it means that part of the activity should focus on the training maybe at school, or training the members, or training the stakeholder of the territory. As I said, the energy cooperative are different kind of a private company. It's a new business, and the principle that we really want to put in first is the cooperation. So usually in the private company, in the classical business model, you deploy a competition model, but for the energy cooperative, it's different. We are cooperating together. And I think with the person who will present today, we'll see that it's possible for private company to cooperate instead of being in competition. And the last principle, it's that the energy cooperative should be really concerned for the community, should include the citizen, and also provide services for the local community. So those are the seven principles of the International Cooperation Alliance. And if some citizen with maybe public authorities or with the local SMEs want to start a private cooperative, want to have those the specific legal form, and if they comply with the seven principles, normally they can be recognized as a REScoop. And those 1,900 REScoop in Europe gather together to make this European Federation REScoop.eu. So this was about the principle and about the way they organize, but it doesn't mean anything about what they are doing. Okay, it's nice for citizens to be together, to create some companies, etc. But why do they do that? You can see here on the right a map of the European citizen cooperative. So you can see that there are a lot in Belgium, in Netherlands. They started actually in Denmark. They are in United Kingdom. They're also in the East countries, so Greece and Bulgaria. It's really interesting to have this presentation today with some Icelandic representative, because there are no citizen energy cooperative in Iceland. So those are the existing citizen energy cooperative, and they are doing several activities as part of the energy market. Some of them, they are producing renewable energy. Some of them are suppliers, like Cositer in Belgium or Energy in Spain. Some of them, it's a little bit more specific, and it depends really of the history of the grid, but some of them owns part of the distribution grid. For instance, in Germany, it was possible for citizens to buy part of the low voltage grid, and so they own it. And as they own this grid, they also can perform some DSO activity, so the distributors. Some energy cooperative provide specific services regarding energy efficiency, renovation, buildings, etc. Some ICT services. Some of them also aim to include citizen, like to focus on energy poverty. More recently, there are some citizen energy cooperative focusing on sharing electrical vehicle, such as Partago, and this is a European cooperative to provide this kind of services. And even more recently, there is this Horizon 2020 project MISSIZE, and the idea was to gather a dozen of cooperatives and to set up a fund to support the deployment of new energy citizen cooperative, or to support the deployment of citizen renewable energy project. For instance, if a local citizen energy cooperative does not have enough funding to invest in a wind turbine park, it's possible that this energy cooperative asks to MISSIZE to have some complementary funding. So those are the activities that are currently achieved by the citizen energy movement. And why is it important for the citizen energy cooperative to exist and to be part of this energy market? There are several advantages of the citizen energy cooperative. First of all, there is this acceptance challenge for renewable energy. So we know that we are, for instance, in the production, we are facing the NIMBY effect, so not in my backyard, and it can be really difficult to develop a wind turbine park or to develop a hydroelectric power plant. And the citizen energy community can act as a buffer between the developer and the citizen. It's possible, like, as I said, it's important to train and to share information with the citizen. So the citizen energy cooperative can raise awareness, share information with the citizen, include them in the process of developing renewable energy. At the end, it doesn't mean that all the citizens will be convinced that it's important to have wind turbines or to have a hydroelectric power plant, but at least they will know why it's needed to have this kind of renewable energy asset, and they will have the information. Also, if they want to join the energy cooperative, they will be members and owners of those assets. So regarding acceptance, it's a really good tool. There is also an important advantage connected to the money. So basically now, depending on the country, because it's really regionally dependent, the renewable energy assets are developed either by public authority or by private company. And we know that the model of the private company is they have shareholders, and they develop renewable energy asset, then they operate it, and the renewable energy asset provide them some benefits. Like you sell the electricity, you can sell grant certificate. Now there are market for LGO, and you have some benefit on it. And the benefit, it goes toward the shareholders. Nothing new, it's the classical business model. The thing is, the shareholders, they can be stranger, they can be external to the country. And so basically you can send the money outside of the perimeter. Here with the citizen energy cooperative, the owner of the assets are the local citizen, are the local public authority, are the local SMEs. So if you want to distribute the benefits, and we know that with wind turbine, we know that with the hydropower electric, etc., the benefit will be shared among the local shareholders. So it's a really good way to keep the money on the local economy, on a local territory. It also brings benefit to society by raising awareness, sharing the benefit among the citizen. There is also a really important advantage linked to the supply, and it is now more important than ever because we know that the electricity price is highly volatile, and we know that now the prices of electricity has really strongly increased. Because it's correlated with the gas market, okay? But basically, when you produce electricity from a renewable energy asset, it shouldn't be so correlated to the gas market because you don't need more gas to operate the wind turbine, or maybe a little bit, but you are talking in Belgium about multiplying by 3 times, 4 times the usual classical price of electricity. So there is this citizen energy cooperative called EcoPower. It's a supplier active in Netherlands, and they own their own wind turbine parks onshore, so on the land. And basically they say, okay, there is an increase of the price of electricity, but for us, there are no more costs regarding the operating of the wind turbines. So basically, we will not increase the price of electricity. And then EcoPower is also a supplier. So at the production side, they do not increase the prices of electricity, and they supply it to the citizen and to municipalities, etc. And they are the only stakeholders in Flanders who didn't increase the prices of electricity. So in terms of resilience, it's really a powerful tool because they own the production assets, they supply the electricity, and they can decorrelate from the market because there is no reason to increase the price of electricity producing from renewable energy source. And it's done now, so it's an example. It's not just something theoretical. Some energy cooperative can also provide flexibility to the grid, so it's another advantage, and I think we'll discuss that in more depth with the H2 cup storage project. And also there is, as I said, a strong focus on the community, and so the energy community really supports the member to save energy by supporting the renovation of the building, by providing maybe some tools to increase energy efficiency, but also by sharing good practices to change behavior and reduce the environmental impact. So now there are here some example about a citizen energy cooperative acting on the different activities of the energy market. So here we have the producers. In Europe, there are some citizen energy cooperative producing from hydropower plant, from biomethanation, from wind turbine park onshore. Currently, there are no citizen energy cooperative developing and operating offshore wind turbine. Offshore is the wind turbine in the sea, so they have much more power and they can produce much more energy. But in Belgium, and now it's public, there are some citizen cooperative gathering together to try to access this market, and so some offshore wind turbine could be owned by the citizens and public authorities and local SMEs. For the supplier, you can see here the EcoPower on the left. This is the logo of EcoPower, and it explains that as they own the renewable energy production asset, they can decide the prices of the electricity and supply the citizen. And you have also some example of other suppliers. So Cositer on the right and REScoop are active in France and in Belgium also, and Austria and some, I think they are active in Spain. About the energy efficiency service providers. So on the right, you can see a figure of Energy ID. So this is not a citizen energy cooperative, but it's a company working for citizen energy cooperative, and they are providing us with some ICT tools. So they help us to better visualize the our production, our consumption, if we have storage asset also to put it, and also they provide some models to optimize the self-consumption at local level. There are some citizen energy cooperative active also on renovation, I told that. And something that's really important now, we know that we need to go together to enter together in this transition, to reach together the Paris Agreement objective, etc. And so it's really important to ensure that there are no citizens, that there are nobody left behind. And so it's really important to focus on the energy poverty topic, because we know that a lot of people are out of the system and it's too complex for them to really enter in the transition. They focus more on money than on the environment. And citizen energy cooperative act as I don't know, a movement who includes everybody. I told you that in Germany, some of the it was possible for the citizen to buy part of the electricity grid, and so this is an initiative, I think, at the west of Germany, where they buy literally part of the electricity grid. So there was they privatized the network, but the citizen gathered and buy really part of the network. And so now they are the owner and they are acting as a DSO. In Spain, there are also citizen cooperative wanting to access the DSO market. And it's possible to own really the infrastructure of the electrical grid. But now we are also developing a new project to own a more virtual part of the network, like to operate what we call a virtual power plant. So it's a little bit more complex, but there are two REScoop Europe projects working on that. Is the FlexScope one and the REScoop VPP. Those are H2020 project led by REScoop Europe. So you can find more information if you want on internet. But basically the idea is to connect some production asset, to connect the consumer, and then to optimize on a virtual basis. And those are the electrical network, but citizen energy cooperative do not only focus on electricity, they also focus on the other kind of energy. So here we are talking about the heat, and some citizen energy cooperative are active as district heating operators. And if there are some questions on that, I think it could be interesting to have the feedback from Sophie, because she will present her citizen energy cooperative in Belgium, and they are deploying, constructing, and operating a district heating. I told you that there is this new cooperative, the Mobility Factory, and it's called Partago, who developed an app to share a car, electrical car, and this is European. So if you gather with some citizen on a neighborhood, you can be supported by the Mobility Factory to access this app, to access the services, and then to share an electrical car with your neighbor. And finally, I also told you that now some citizen energy cooperative identify that at local level, sometimes it's difficult to access the funding, and so they are gathering to set up a new funding called MISIZE. This is also a Horizon 2020 project, and the idea would be to access 700 million euros fund to support the deployment of citizen energy cooperative project. So we are really talking about a new paradigm. It's not a small movement, it's a European movement, and they are active on all the activities of the energy market, and they are developing tools to reach this objective. So about the energy cooperative movement, I hope you understood that it's more a social concept. It's a way to organize. It's a way for the citizen with public authorities and SMEs to reappropriate the electricity or the energy to own. It's a new way to collaborate, to make cooperation instead of competition. And it's kind of neutral regarding the activity, because as you could see, there are some citizen energy cooperative active in all the activity sectors of the energy market. So this was the first part of the presentation to explain a little bit what is the citizen movement growing in Europe. And the second part is about the clean energy package. So as part of the clean energy package, there are those two directives that must be translated at the national of Belgium, for instance, at the regional level. And those are the Renewable Energy Directive 2 and Internal Electricity Market Design. And they defined this concept of energy community. And now I will talk a little bit more on that, but I hope I will not come into too much details. So basically,
also, Lionel, time is running short a bit. So
okay.
If you could summarize what you want to say, because then we can move on. So perfect. That we keep in time.
No, it's perfect. It's the last slide. So in short, those two directives, they define new stakeholders, such as the renewable energy communities and the citizen energy community. The idea is really to recognize the work carried out so far by the citizen movement and to make a definition so they can be recognized. So it's really important now, normally in the law, in the local and regional national law, there will be a definition to recognize this movement. And so it will not be possible to to hamper the how can I say? Yeah, so it's really important to define, so they have a regulatory framework. And in second time, the European Commission enables some support mechanism to support those energy community. And this is important because it's not only we will recognize and give you a definition, it's as you have some really positive impact on the society and the environment, including the citizen and public authority in the movement, we will provide you with some support mechanism to continue your work. So this is really important. And now there is this work to translate the directive at the national level. And this is a huge opportunity for the citizen movement, either in Belgium, to recognize the activity carried out so far, or for the new countries where there is no citizen movement to deploy it, okay, such as in Iceland. So I think I can end here now. Thank you, and yeah, maybe it's better to answer question. And I hope.
Thank you very much, Lionel. I think this
you.
was a very nice overview of our citizen cooperation. I think we can give Lionel a big applause, virtual applause. And I think the message was very clear. So anyone can get involved in energy cooperation now with this citizen cooperation. So if you have a question, a short question, please feel free to do so now. Otherwise, we would move on. And I would like to ask the next speaker, Hafsteinn Helgason, to prepare the slides, to share his slides. And meanwhile, we have time for a very short question. Okay, if there is no question, then I will give the floor directly to Hafsteinn Helgason. Hafsteinn, can you share your slides? Yes. I think you're still muted. You have to.
Yeah, can you see my slides now? Hello.
But perhaps you could go into presentation mode.
Can you now see my slides?
Yes, perfect. We can see them. Thank you.
Okay. Yes. Good morning, everyone. You know, if we are talking about converting systems and bring hydrogen to energy consumers like steel industry and other industries, we should look at the location of those industries, you know, and indeed not only in Europe, it is worldwide the case. We see this industry located as well as cities near to the biggest rivers on earth. And this is the case, for instance, for the river Rhine and also the Donau and other rivers we know very well. And so we also know that where this industry is located, we do not have renewable energy production available, you know, very little. Of course, in Austria, you have a lot of hydro, but this is not all over the case. So the question is how to bring the hydrogen to those consumers. And we studied that very carefully, and we have been working on this, I would say, more than 4 years, in 4 years about. And we have been studying different ways how to bring the hydrogen to such consumers. And we have come to the conclusion that the liquid hydrogen is most likely the best way. And we also see that technology providers, for instance, the truck industry, is more and more talking about liquid hydrogen as a fuel for such vehicles in future, not hydrogen in form of gas, as we see today even. So I will now go through some slides from a project we had this earlier this year. and was funded by different bodies, also from Europe, but also from Iceland, and is about production of hydrogen in Iceland due to our access to renewable energy and reasonable, good prices, and bring it in liquid form the River Rhine to the port of Duisport in Duisburg. That is in the middle of the Ruhr area. You can see the distance is around 2,200 kilometers, and it takes 3 days to take the boat from, in this case, we decided to calculate everything from the port of Thorlakshavn in South Iceland, 3 days to Duisburg, and 4 days back with the empty vessel. And it takes longer time because of wind and weather situation normally in this area. We decided to calculate everything for the use of standard ISO containers for the liquid hydrogen, and use a normal small container vessel for this transport. So that means per delivery, we will take 140 feet containers to Duisburg. And as you may see, that boat has to cross the North Atlantic, but also be able to go up the river. And that is especially of interest because hydrogen as a liquid material is not heavy. So the boat is not going deep down into the river. So we set up this scenario. We have the factory near to the harbor. We produce hydrogen from electricity from the grid as well as from nearby wind parks, and we convert the hydrogen into liquid form and export it in containers, as I said. We have byproducts here from this factory. We have oxygen, of course, because we are producing a lot of oxygen. And the oxygen will go to the nearby fish farms. And that is very interesting because in this area of Iceland, we see now big growth in land-based fish farms, salmon farms. And we have also the rest heat from the electrolyzers we could use to heat up the seawater up to the optimal temperature for the fish to grow. And not less important, if we are producing hydrogen in a large scale, I would say, then we are also able to deliver hydrogen in form of gas to the capital city, Reykjavik. It's only 30 kilometers away. And so we could service fuel stations there with gas under pressure. So we know, of course, that it costs a lot of energy to turn hydrogen in gas form to a liquid form. And it is approximately 8.5 kilowatts per kilogram of hydrogen. But as I said before, the beauty is that a cubic meter of liquid hydrogen weighs only 72 kilos. And we know also from this project and other projects we have been working on that the economy of scale in this business is very important. So in this project, we decided to cooperate very closely with the US company Chart Industries. They are also active in Europe. And they are operating factories in Europe also for technical systems. And as I said, we use the standard ISO container produced by Chart Industries. and we could put in 3.2 tons of liquid hydrogen per container, and the empty weight of such a container is around 13 tons. And we delivered, the vessel could take 110 containers per delivery. You can see those systems on those photos on the left side, the containers, the main production unit for the liquefaction on the photo in the middle, and land-based stationary storage tanks on the photo below that, lying tanks in horizontal lying, line. And so the vessel will take full containers to the port of Duisburg. There, those containers will go to 3 off-takers. All off-takers, they have tanks, as you can see on the picture down left, and with the boil-off gas, because during the transportation over the sea, of course, a part of the hydrogen is turned to gas. So the pressure in the container has been growing. And with the pressure from inside, we push the liquid hydrogen from each ISO container into the stationary one. But we have to keep a portion of the hydrogen in liquid form in the ISO container for the trip back to keep the skin, the inner skin of the container cold. And otherwise everything will turn to gas when we fill it up again in Iceland. So it is very interesting to see how this works. And it will only take around 2 days to empty those containers and send them back as almost empty on board the vessel, so long the vessel is waiting in the port, and it goes to Iceland again. The loop will take around 14 days. As I said, the oxygen in liquid form or in a form of gas via pipeline will go to the nearby fish farms, and no boil-off gas will be released. So in this case, we calculate everything for 8 wind turbines, and the rest of the energy came from the grid. And we calculated this for alkaline and PEM electrolyzers, total yearly production of around 7,000 tons. And it's very interesting to look at how much you can get for the byproducts if that is going to if the market is going to behave like until now. So it's around 4.9 million euros per year. But if we take a look at the chart, you can see that the wind farm, the investment for the wind farm is approximately 19% of the total capex in this case. The hydrogen factory, around 20%. Liquefaction plant, more than 100 million euros. And the transportation, logistic cost, the vessel is in this, and the containers, they are very expensive. It's around 26.6%. So we have found out that those positions number 3 and 4 can be optimized, and we are now going to step into some kind of optimization of those two parts, and we do hope that we can take the price of the hydrogen very much down. But if you take a look at Iceland and compare Iceland with Austria, because we have partners here on the line from Austria, you know, the countries are in some way somehow similar. You know, we have a little bit bigger country, 103,000 square kilometers, but only 1.3 million inhabitants. Austria with 84,000 square kilometers and 8.9 million people living there. So both countries are have mountains and highlands. So a part of those countries are let's say with dense populated areas. Here in Iceland, we have been working on a project called Finnafjord project in the northeast of Iceland, where we are going to have a new industrial site, and here we will have a large-scale hydrogen production in future. There are even today companies looking into the Finnafjord site as the ideal site for this production, liquid hydrogen or ammonia, and that's mainly because this area is not very dense populated. We have only a couple of hundreds of thousands of people living in 2 villages there. Most of the land there is not in operation as such. You know, it's owned by people living here and there, and so the land is more or less unused. So we are now developing 6 wind parks in this area together with those landowners and the municipalities, 2 municipalities. So in this area, we will in near future maybe be able to deliver 2 gigawatts of electricity to the Finnafjord area. And that is, of course, something new and could change a lot. So this is the Finnafjord during the winter time, 2014, no ice, almost no snow. Wind is very interesting there, mainly coming from 2 directions, and the average year temperature there is lower, is around the same or even a little bit higher than the average air temperature in Manhattan, New York. So it's an interesting site. It is flat land, no rock to blast. You can, you know, almost start your construction work at site, and the sea is deep. Port development is easy there, and that is one of the points those companies we are discussing with are very much interested in this site. So if we conclude a little bit, we can see that this is really a business case. We have to face the fact that the technology is almost there, is not fully there. For instance, this vessel I'm talking about, we cannot see a vessel of this kind on the seas today, but all the parts we need, they are developed. So there is a need for special design of this vessel for this transportation. We also see that there is a need for a gigawatt plant to take the prices down. And the whole logistic must be optimized. The vessel itself, the tanks, etc. And we do think that the model will look like the following. We will have a vessel with fixed tanks in the vessel, but that vessel will also take some ISO containers over the sea. That means in the port of Duisburg and maybe in Linz, who knows, will the those ISO containers, they will go straight to some smaller customers, but the bulk, the biggest part of the hydrogen will be taken out from those fixed tanks on board to fixed tanks close to the industry which is going to use it. It is, of course, necessary in this case to prepare deeper financial calculations with the involvement of the off-takers and the shipping lines. It is needed because we are talking about totally new things we do not have on Earth today. We have only one vessel bringing liquid hydrogen today from Australia to Japan, and that's quite a new one. But we have to learn from that and maybe prepare something different, because this vessel must go up the rivers as well. The target is to get have the cost of the kilo below 4 euros. It could even go to 3.6 euros. That depends how the logistic cost will be. And we are open for cooperation, as was mentioned here earlier. Cooperation is the way to succeed, and especially on the logistic side regarding the vessel and tank solution on board. Thank you.
Thank you very much, Hafsteinn, for this very interesting and very important talk. I think we can give a big applause to Hafsteinn for a virtual applause. So if there are any questions, I think Hafstein's talk links to some of the projects that some students are looking into. I'm thinking of the wind farm and the exporting electricity, and also the industrial symbiosis between hydrogen production and fish farms are very interesting, and we have also discussed it yesterday. So if there's a question, please feel free to ask Hafsteinn now. We have a few minutes left, and then we'll proceed with the next presentation. So I think Hafsteinn, there's a question in the chat, and I'd have to read it over here. Yes, Hafsteinn, I think there's a question with the planned expansion, if there's an additional symbiosis.
Also expected to that byproducts auction will increase. You know, if you are producing hydrogen, you are producing much more oxygen, and oxygen is a cheap product, so you will never transport oxygen for long distances. Therefore, in the port of Finnafjord, we do not foresee large fish farm there, but maybe one land-based up to 80,000 tons of fish will be built up. We are in discussion with companies about that, but that farm will only take a small portion of the oxygen from a 1 gigawatt factory. Next question, what are some components of wind park, and are there designs for the concept? Yes, we have pre-designed those wind parks, and we are about to start wind measurements. If everything goes well next year, those fields are very big, but we have most likely wind situation on land, as we can see offshore in front of the coastline of Germany and Holland. And this utilization factor will be most likely around 46–47%. Yeah, that about the rest heat from the electrolyzers. Yeah, this is a possibility to do, but this will also need a very deep investigation together with those producers of the electrolyzers and the industry. The cooling system of electrolyzers is mainly with fresh water, but we have to heat up seawater. So we have to bring the heat from a closed loop system into ocean water. And that is, of course, done by, with heat exchangers, but this is something we will work very carefully on together with industry when it comes to that project. You know, just to mention that those projects we are talking about, they will be realized in the years 2027, 2028. So it's future, very much future related.
So thank you again. I think hydrogen is really an important part to decarbonize the industry, like we have heard yesterday, or for example, in Linz with the steel production. It's one way of replacing the coks needed or the carbon needed to produce steel is by replacing it by hydrogen. And for this, huge amounts of hydrogens are needed. In Austria currently, it's not possible. It's impossible to produce sufficient hydrogen to fulfill the requirements for the steel production. So solutions like Hafsteinn presented are one way of proceeding, and that's why I think it's a very important part in the plan of decarbonizing the industry or becoming climate neutral.
Maybe one thing to add on, you know, this hydrogen for Linz don't have to come from Iceland, can come from Turkey or from offshore wind parks in the Black Sea, you know.
Of course, we had yesterday also a talk from about North Africa, so this is also a solution, and of course the Middle East could also be a solution, and at the end there are multiple solutions possible. So I think we're gonna, is there a further question? I think there's one last question. In the meantime, I would like to ask the next speaker, Helgason from Mannvit, to prepare his slides, but maybe we can answer quickly the last question.
One question to me, you mean?
Yes, there's a question if a wind park like this could be a citizen cooperative movement, could be included in a citizen cooperative movement.
You know, everything is possible, but you know, we are talking about 235 big turbines, and you know, those communities there, they are small, you know, a village with 120 people living, and to be honest, you know, those guys there, they are not very much saving electricity or thinking about prices of electricity, because in Iceland the prices are low, very low if you compare it with prices in Europe. So people in Iceland, they are not behaving well, you know, but they are earning good money, and this bill is not the highest one per month, you know. So I think they are happy with the system as it is today, but who knows?
So thank you very much, Hafsteinn, Helgason, for your presentation. I think we will move on to the next presentation. Obviously, the involvement of citizen cooperation needs a lot of discussions, and we might not be able to solve it today. But I would like to introduce the next speaker from Mannvit. It's not Friðrik Ómarsson, but I think it's Helgason. Am I correct?
Yes, you're correct.
Yes.
Do you hear me? Yeah, okay.
Yes, we can hear you.
I'll share my screen. Do you see my screen now?
No, at least I cannot see the screen yet.
Okay.
Um,
Let's see. Okay, sorry, one more. But what about now?
Still not.
Let's see. Okay, need to push one button here. Sorry.
Yes.
Now you see it. Now you need to see the
Now we
presentation.
can see it, but we still see your desktop. We don't see the slides. We
just
see
a
your
moment.
desktop.
And now you see the screen, I suppose.
Yes. Now we see the screen. Thank you very much.
Sorry for this. Yeah, as said, my name is Þröstur Helgason. I'm working at the company Mannvit. It's a consulting company in all disciplines, but also in green energy mostly. Yeah, we provide all kinds of services, engineering services, and energy services in the green energy business. I'm just going to go a little bit to the company and then our experience in the eastern part of Europe or the Balkans. Mannvit provides all the services in geothermal and geothermal engineering, both the early preparations and resource assessment and reservoir engineering and environmental impact studies and things like that. All the necessary steps to start the geothermal operation. We have a lot of companies which have been our customers through the years, energy companies in the field of geothermal in many parts of the world, so we are quite known in the geothermal market. We have subsidiaries in various places in the world, and as you maybe, if you know the geothermal world, these subsidiaries are mainly located where there are possibilities of geothermal energy production or use of geothermal. We have a company in Indonesia where there's a lot of geothermal possibilities, and we are working there. Also in Africa, we are working in some projects, in drilling projects in Africa. And then also in Europe, mainly Eastern Europe, the eastern part of Europe, we have a subsidiary in Hungary and in Germany. The subsidiary in Greenland is not related to geothermal. It's probably the only subsidiary that has nothing to do with geothermal. There's no possibilities of geothermal in Greenland, unfortunately, but there are other green energy possibilities anyway. But in the past, we decided from our experience and what we had learned in working in Iceland for many years, we decided to export our knowledge in geothermal utilization into Europe, and we got into some projects both in Germany and in Hungary. Those are the warmest areas. I don't know if you see my mouse, but the Pannonian Basin, which is located where Hungary is one of the warmest area in Europe, and we got a project there through some European connections and funding, and decided to start a company there in Budapest. At the same time, or a little bit earlier, we also got into some projects in Germany, and it's also related to a company there. But geothermal utilization has been going on in the eastern part of Europe for some years, and with growing emphasis. For example, in Hungary, there's now in the past years much more interest for geothermal. due to these CO2 problems that we have in the world. And the main two green energy possibilities or emphases that are in Hungary are the use of geothermal and also the use of solar energy. And we are participating in those industry through our company in Hungary. Our company in Hungary, it was established 2007. It was started to work on geothermal projects in Central and Eastern Europe, and also in general try to access the green energy market in this area. This area, the Balkans and Hungary, Romania, these areas, they have huge possibilities in producing energy in a environmental friendly manner. In Hungary, they have the Pannonian Basin, which is a huge resource of energy in the under the ground, and also huge possibilities in solar energy. The Balkans, they have a huge possibility in hydropower, and also some possibilities in wind. But the further you go to Croatia and in that direction, the less you have in possibilities in geothermal. But in many countries in this area, you have geothermal possibilities, although they are maybe on the bigger scale in Hungary, and also maybe when you go further to the south, all the way to Greece and Turkey, there are also huge possibilities. But we have developed this company to work in this area. Just as an example of projects we have been working on. In many cases, it is different. It is difficult to attract investors to work on geothermal projects. But in this case, there were a lot of good opportunities for investors, and the location location is near to a big city. It is undeveloped area with a good potential for geothermal, and in this case, Chinese investor, or partly Chinese Icelandic investors, was interested to build a power plant based on geothermal. It's a power plant that gets the geothermal fluid from wells. I think it's about 2,000 meter wells, and the temperature is around 120, 130 degrees. This is put into turbines and so-called ORC technique, which is used, and there are two steps of turbines, and the production of electricity is through these turbines, and the waste heat from the electrical production is used to heat houses in the area. So the utilization of the energy in the ground in this case is optimum, we could say. It's both used. The higher temperatures of the water is used for electricity production, but the lower end for heating houses. And this is a good way of doing things. And then the fluid which comes from the houses is re-injected into the reservoir. So the rest heat, which has not been utilized, is put into the ground again. These are just some pictures from the site when it was in construction. And this is the plant, as it looks today. It's on a huge field that is mainly agriculture field, and the factory actually doesn't take too much space, and rather compact and connects well to the area, neighboring area. Although there's a large field, it's also near to consumers. So it's a successful project where a project which is funded by private money and has proved to be a good investment. We are also now working on just in the early phases of a project of heating Budapest by use of geothermal. Here we are using the experience in Reykjavik. As you maybe know, Reykjavik is more or less heated by geothermal. And there are huge possibilities in the Budapest area to use geothermal in much greater extent. Until recently, the authorities in and around Budapest have been very much against using geothermal for space heating. This is because of it is because the culture in the Budapest area and in Hungary in general is much related to spa use of geothermal, and there's a lot of tourism in Budapest which is relying on spas and some medical use of geothermal fluid. But it has been, you know, researchers and institutions have been investigating the possibilities in geothermal use in Budapest, and the result is that, you know, taking from the reservoir in the Budapest area will not affect the use of geothermal in the spa part, which they were afraid of. So this is a very promising project, and we hope that it will be a good way to decarbonize and to take down some of the pollution in Budapest. There are also a lot of small municipalities that we have helped to utilize geothermal in small scale, small villages, and we have been working in the area also. There's also a project in Croatia which is similar to the Tura project, producing electricity and providing heat. So it's a rising demand for our work in the geothermal business in Hungary. So people are beginning to realize that there is a lot of energy hidden underground which can be used in these areas. These are just some examples from other areas in Hungary which we have been utilizing. But mainly these installations are not for electricity production, but only for generating heat for district heating. We have also been working in the neighboring countries, but mainly for doing feasibility studies or going through the possibilities that are in the geothermal sector in this area. We have also tried to introduce some technologies in cooperation with Swedish companies in introducing possibilities of producing electricity in smaller scales for where you have maybe existing well, and you can get maybe 80 to 100 degrees geothermal fluid up through the wells, and then there are smaller units that can maybe produce maybe 150, 200 megawatts, no kilowatts, sorry, which can be installed rather easily. These units are also beginning to be used in Iceland. one of the as the ambassador for Europe was speaking in the beginning, there are a lot of challenges and difficulties that companies like small companies in Iceland, although Mannvit is relatively big companies in Iceland, having between 200 and 300 employees. It is a big challenge to go and try to convince municipalities or cities or governments in other countries to start to use geothermal resources. If often in the beginning we start cooperation or get into contact through with municipalities or companies or some partners in these areas through conferences like these ones we are on today, and from there we try to finance the first steps of some investigations or measurements or see if there are possibilities within the areas. And for this we use EFTA grants, the EEA grants, which is some kind of aid from the EFTA countries to help development in green energy in these areas. And also we have also used some funding from NOPEF, which is a Nordic fund for marketing. When we go to these countries, for example, in Eastern Europe or the Baltic countries, we meet a lot of challenges in licensing, permitting. There's also the language barrier. Often English is not very much used in some of these countries. Laws and regulations and cultural things are difficult sometimes. And in most cases, we need to start companies. We need to, if we are going to have success in these areas, we actually need to start a small company. We need to hire a director. We need to hire an accountant and a lawyer to be able to go through all these things, which are licensing and all these things we need to go through to be able to get into do some work in the area. We also need to do some risk assessment studies to be able to access some funding institutions. We need to do, there is always a lack of local investors. There's not a culture for using geothermal in energy in these areas. So local investors are, they think it's too much risk, or they have not possibilities to do some risk mitigations regarding drillings and things like that. There's a cultural difference. We are here in Iceland are maybe used to jump into things and just do things, but in these areas we need to go through a lot of bureaucracy and learn how things are done in these countries. And all this takes a lot of effort, and this for us very expensive. It's also a problem in these countries that the focus of using energy from the ground is always on producing electricity instead of heating. This is gradually changing. Now people are getting more and more interested in using the heat as a source instead of producing electricity. It has also been a problem that the gas has been the gas prices have been very low in these areas, and so the financing of a more expensive geothermal solution has been difficult. But now it's mainly due to COVID, I think. gas prices are much higher, and governments or municipalities are beginning to think in another way. It's not only that they want to decrease carbon, but also they want to be more self-sufficient in energy production, or so they don't want to be relying on other countries in terms of energy. So that has also helped us a lot in marketing geothermal energy or green energy in general. Just to introduce the process of our project. Normally we start in some surface studies and possibly do a pre-feasibility study to see if things are possible. After that, we need money into the project and to do some measurements and do some test drillings and things like that. And this part is often very difficult. Often we do not get past pre-feasibility, although the projects are maybe feasible. Financial institutions or companies, they feel that the risk is too high. So, but if we get further, we get into some test drillings and things like that, the risk becomes less, and companies begin to be more willing to participate in this this process. But I feel that, you know, when we started, I thought this was very simple. We could easily start many projects in this area, in this part where there are a lot of resources. But now, you know, 20 years later, it's beginning to be more or easier. People are beginning to look at geothermal as a valuable asset. We have actually been working in Romania for many years, and we have done a lot of studies and a lot of work in especially the eastern part of Romania and around Oradea and Timișoara. And now, yeah, we have actually started two small power plants in this area, but now it seems that the interest is beginning to be much more on geothermal. So it seems like that we are going to be successful. For example, in Oradea. Oradea is a city approximately the same size as Reykjavik, and resource-wise, it would be possible to heat all of the city with geothermal, but it's now heated with gas and coal and in very inefficient manner. So there are huge possibilities there, and this is also the case in many other places in Eastern Europe. But now, when the gas prices are getting lower, no, getting higher, it begins more interesting for these areas, these municipalities, to go ahead with the projects. Same goes in Serbia. No, in Slovakia, there are a lot of geothermal possibilities. We have been working in the Košice areas, and we did a feasibility study there, which when it came to the financing part, the financing institutions decided that it was too risky to go ahead with drillings. Same goes for a small town, Trebišov, Rano. The risk was too high for starting the projects, mainly because the drilling cost is too high. Here in Iceland, we have this one of the reasons for the huge use of geothermal here is because the state for many years ago decided to take the drilling risk. So if municipalities or companies were trying to establish geothermal energy, the risk of drilling was not an issue, or much less an issue as it is in these countries. So, for example, if the European Union would help on mitigating the risk in drillings, it would be much easier to start geothermal use of energy in many places in the areas I've been talking about. So the risk of drilling is the main obstacle. We also done a project in Bosnia and Herzegovina. There we did all these things I was describing. Started the company, hired managers, hired lawyers, went through all the processes of licensing and public procurement and all these aspects, and did some geothermal research and risk evaluation. And we had a project which was more or less ready, but with certain risks, and the risks in drilling and doing all the tests that need to be done in the next phase of the projects were simply too high, so it was not possible to finance. And again, this is mainly the risk of drilling. Drilling can cost, a lot of money, and maybe if there is a 50% success rate, then financial institutions are not ready to take this risk. It's easier to install wind turbines or solar cells or something else. It is not as risky. We also been doing similar things in Bulgaria, Greece, and Slovenia. We have funding applications in Slovenia to do some very interesting projects in producing electricity to use in the tourist business, to provide energy to charter ships and other consumers. We are also funding projects in Bulgaria and trying to establish some geothermal use in these areas where there are also good possibilities there. In Slovenia, now in Greece, we have also actually signed a contract for a good project in Greece, maybe 20 megawatt project in Greece. There are huge geothermal possibilities there, and mainly competing with wind and solar energy, of course. But this is gradually developing. This was all I had for today. We are still working a lot in these areas, and we see that the environment is getting more friendly for companies like ours to do business in these areas, and we look forward to the next years in this. Thank you.
Thruster, thank you very much for your talk. Very interesting talk. Also, especially interesting for us at Reykjavik University. We do have research projects with Banja Luka, with Belgrade, and also with Timisoara. And it would be nice to follow up on a discussion perhaps. Next week, if COVID allows it, we will have a visiting professor from Banja Luka who is aware of your project involvement in Banja Luka, and perhaps we could get into a discussion further on this topic.
Yes, we would be very interested to do this, and actually I think I have met this professor you are referring to. So just be in contact and we organize something. We are very interested to, as we are on a conference like this, it's here in Iceland, we need to have more cooperation between universities and companies. It's sometimes we have more cooperation with Danish universities than Icelandic universities in some cases, which is not good.
So the Professor Peter Guerro from Banja Luka University, he will visit us next week, and hopefully, if COVID permits it, if the restrictions permit it, we will have a presentation from him on the energy situation in Banja Luka, where it would be possible to install geothermal district heating, which would help really the situation in Banja Luka, where you have during the winter time, during inversion, and when you don't have any wind, terrible air quality, and you could improve it with district heating. So please give a big applause to Thurstor Helgason. And if there are any questions, please feel free to unmute yourself or type the question into the chat.
I have a question. Okay, and on your first slide, you showed one of your first slides, you showed the different points of where geothermals, and I don't really remember whether you said Mannvit is also operating in Kenya or in East Africa. Is it the case or not?
Yes, it is the case. We are working in Ethiopia.
In Ethiopia.
It's
which area? Which part of Ethiopia?
It's called Tulamoya.
Okay.
It's a project which is actually it's a company here in Iceland, Reykjavik Energy, which is in a large part owned by some American investment funds, and they have been trying to or have started development of geothermal utilization in this area in Ethiopia, and we are the main engineering consultant together with another Icelandic engineering company.
Okay, but not yet in Kenya or just Ethiopia.
We have actually been involved in projects in Kenya also, but none of it is active today.
Okay.
Yes.
There, you know, this area, Ethiopia, Kenya, it has a huge geothermal possibilities.
Yeah.
The Rift Valley, or I think it's called, which is
the Rift Valley.
Yeah, which has huge geothermal possibilities, and there in this area where we are now working, there have been, I think, 2 drillings, and they are working on the 3rd one. The drillings have not been as successful as planned, but they are, you know, trying to find the best location for this geothermal utilization, and I think the plan is approximately 300 megawatt geothermal power plant. So there are large expectations.
Daniel,
David,
thank you very much for the discussion. Maybe
I have a question to Thruster. Can I ask a question?
If it's a short question, yes.
Yeah, it's a very short one. You know, we at Efla, we have also been working abroad in Asia, Africa, and in Europe on geothermal projects. And one of the problems is that the heating period, let's say in Croatia or Hungary, is very short. So we think that the use of this energy should be focused on use in industries, where the use is also during summertime. How is it on your projects in Hungary? You know, how long is the heating period?
Yeah, the heating period. This is of course in some cases difficult. In these areas, the heating period is relatively short, maybe 6 months or something like that. So it's very good if you can in some way combine the use of the energy from the ground. You know, if you can partly use it for space heating, partly use it for agriculture things or industries. So we as you mentioned, we try to blend the use so that we can utilize the heat more evenly throughout the year.
Okay.
Okay, thank you very much. I think there's a lot to discuss, and I hope we can continue this discussion perhaps after the seminar, perhaps go into a collaboration even within a research project, or even perhaps an EEA grant that we jointly work on, or proposal that we can work on proposal. So I look very much forward to continuing this discussion, but we will continue with the next presentation. Thorsten, could I ask you to, yeah, exactly,
Yeah.
Thank you very much. And the next presentation is about the H2COP storage project, which links directly to the presentation that Hafsteinn presented before, hydrogen production in Iceland. In this project, we compared, actually Reykjavik University is directly involved in this project, and we did the life cycle analysis for hydrogen production in Iceland, transporting it towards Europe. So, but I'm not going to talk much more because Lionel Delchambre, who already presented the citizen cooperation, energy corporations, will present, is the leader of this project, and he will present the H2COP storage project.
Okay, thank you, David. So indeed, now I will oh, sorry, be in my role of employee of CLE. So this is one of the 1,900. Just a couple of words. It's a cooperative gathering more than 1,500 citizens, and we are reaching 4 million euros. So you can see what is exactly one of the 1,900 cooperative. Here is a map with the project and operation. We have 4 project wind turbine under operation, and there is 1 project under construction. And the gray square are the project under development or under construction. And this is only 1 citizen cooperative. So basically, the movement is growing in Europe. But today I will talk a little bit more about the H2COP storage project. I think this is the point. And this is, yeah, maybe one thing. This is the 40 citizen cooperative active in Belgium. So there are 40 like mine. So basically it's, we are operating a lot of energy production assets. Okay, let's focus on the H2COP storage project. So this is a European project funded under the ERANET framework, and basically we need to collaborate with different regions. There are 8 members coming from 4 different regions across Europe. There are the University NTNU from Norway. There are experts in hydrogen safety. There is the team of David. So you said that you are carrying out the life cycle assessment, life cycle analysis, but also you are conducting other kind of studies, more sociological studies. There is ZuidtrAnt, who will present itself just after my presentation, I think. And there are 5 members from Wallonia, another region in Belgium. A university, my cooperative, also one of the REScoop. There is also a research center called Senaero to make the modeling. A subgroup of NG, and it's a little bit difficult because some of you know that NG is restructuring now, and so they will not be part of NG in the future. And Memoco is a European company working on monitoring. Oops, my apologies for that. And around the project, there are a lot of external experts coming from the academia, coming from the cluster. So cluster 2 is for sustainability. WaterSoftNet is the cluster of hydrogen in Flanders. There is also some regulators. But here you can see the partners and the members of the project. The idea was to integrate hydrogen storage solution within energy communities. So I've defined slightly what's energy community, and I will not go too deep in details. And to integrate this kind of hybrid storage solution, we identify with the consortium different barriers hampering the deployment. So we identified that there was a need to better understand the regulatory framework. This is a huge barrier now to deploy hydrogen. There is no homogeneity among the regulatory framework in Europe. Also, we want to get the reversible fuel cell closer to the residential areas, and the risk analysis are not adapted for that because the hydrogen is mainly used now for the industry. And if we want to close reversible fuel cell to the houses, to households, to citizens, we need to develop new risk analysis. For the life cycle assessment, it was important to develop and to gather more data about the new technologies, the new reversible fuel cell. Also, we know that there is also this NIMBY effect regarding hydrogen. We wanted to better understand what are the barriers of the stakeholders to deploy hydrogen, and we wanted to better understand the feeling about it. It's needed to develop new business model because we are developing new activities. Then we wanted to develop software to better setup and like size and manage an energy community with such kind of hybrid solution. And we talk about hydrogen for a long time, but now it's really needed to set up demonstrators. And so for each of those barriers, we define tasks to be carried out as part of the H2 coop storage project. So for the regulatory framework, regulatory analysis, for the risk analysis, NTNU will develop new risk analysis, new models. For the environmental study, David's team will perform a life cycle analysis and has already started to do a stakeholder analysis, a closed loop diagram. We are working on the new business model also, and we are developing a sizing tool and an AMS, and the sizing tool is now, like a first version is now released. And the idea is to really set up a demonstrator. I will talk about that later. And so here you have the member in charge if you want to see where the expertise rely in the project. And some members are in support to help the academic partners to develop their task. Okay, so we have identified all those barriers and we address these barriers with the task, but the idea is to set up real demonstrators. So we wanted to have a real pilot site, and there are 3 pilot sites. There is the one in Iceland, the Lucie geothermal power station. And so the renewable energy is produced from the geothermal power plant, and the members of the perimeter of the energy community are the industry, the households, and the tertiary sector. Basically, it's the entire Reykjavik city and possibly the industry near the geothermal power plant. So it's a huge perimeter at the city level. In Mörtelside, it's a smaller scale perimeter. We are only at a neighborhood level, so it's a smaller project. The renewable energy is produced from solar, and the members of the perimeters are the tertiary sector. So basically on this site, this is a collection center. They receive some old clothes, some old equipment, and they are sorting it and reusing it. Okay, it's a circular economy plant. And in Nivelles, this is also a smaller scale project. We have the renewable energy is produced from wind because there is a wind park and we own part of this wind park, and from solar. And the members are households and also the tertiary sector, such as the hotel that you can see on this figure. Maybe to deepen a little bit the technical details. So this is a picture of the Mörtsel site, and you have basically 3 buildings. The one is our offices, the second is the collection center, and the third one is the warehouse. And the idea is to install a 450 kilowatt peak on the roof of the warehouse and to share the energy with the offices and the collection center. Because we know that in the warehouse and there is almost no electricity consumption. As I said in the question, when we produce hydrogen with an electrolyzer, we produce heat also, and we would like to valorize this heat because the efficiency of an electrolyzer can reach 60% when we only consider the transformation of electricity within hydrogen. But we think that we could reach theoretically 97% if we can valorize the heat for the entire energy efficiency. So this is what is said in the literature, and this is also important to demonstrate that to see what is the real efficiency. And so the reversible fuel cell will be put near the collection center. And the idea is to balance the electricity. When there is an excess of electricity, we produce hydrogen. And when there is a need of electricity, we transform back hydrogen into electricity. So the naval site is a little bit the same map. So we have vertical households. Those are the .1 and the .4s. Those are consumers, and it's vertical households. So they don't have a lot of opportunity to produce PV because there are not a lot. There is no superficie to install PV, but there are huge superficies on the number 6, the number 3, and the number 2. So the 6 is a mall, and the number 3 is the hotel, and the number 2 is the is a retail store. And so it's the same. The idea is to locally balance and to avoid congestion. And we would like also to valorize the heat within the hotel, because a hotel is a huge consumer of heat. And so the idea would be to put the reversible fuel cell near the hotel. To give an idea, for the Motzal side, the idea would be to install the reversible fuel cell in a couple of weeks, and in Nivelles, maybe at the end of 2022. And the third side is LHID. So we have discussed about geothermal power plants. So I assume you know a little bit more about this site, but there is the LHID geothermal power plant. The power is 300 megawatt, producing electricity for the industries, but also for Reykjavik city. Reykjavik city is the main consumer of this electricity. It's also producing heat. And there is a district heating linking the geothermal power plant with the city. And basically now there is already an electrolyzer. It's an alkaline electrolyzer. And the objective of the hydrogen production would be a little bit different, because it's only an electrolyzer. So it will be more difficult to use the hydrogen to balance the electricity. So the applications are slightly different, but I can present it now. So for the hydrogen production, and to focus maybe on the hydrogen part in Mortsel, the idea, I've said it, is really to apply hydrogen for constraint management and balancing. So really when there is an excess of electricity, you produce hydrogen. The technology, it would be a PEM. And we assume it's a good technology, but it's a rather low temperature technology. So normally, theoretically, the temperature should reach 80 degrees Celsius degrees, but from the experience that we have so far, it reached 65. So it's difficult for the district heating application. The electrolyzer mode would reach a power of 5 kilowatts, and in the fuel cell, so in the other direction, so electrolyzer is transforming electricity into hydrogen, and the fuel cell is transforming back hydrogen into electricity, would be also 5 kilowatts. So you can see that the power is really undersized. We say that we want to install 450 kilowatt peak of PV, and so it's totally undersized. But the idea is to have a demonstrator to see, to verify the efficiency, to validate the business model, to see how we can implement, to see what will be the regulatory barriers, to see also what kind of permitting procedure. So in the geothermal presentation, we discuss about the permitting barriers, and we assume that we'll have some also with the hydrogen. So it's a small one, but it's a demonstrator. In Nivelles, the application would be the same, constraint management and balancing, but we didn't decide yet what kind of technology. We would like to try a SOFC. So basically it can reach 800 Celsius degree. So 10 times the temperature of the PEM, and but it still needs to be defined. And then for the LHID side, I said that the applications are slightly different because we discussed with one of David's colleagues, and he told us that at the beginning they were thinking about using hydrogen for balancing. Then it's more on the high voltage grid. But with only an electrolyzer, it's difficult to balance. So mainly the application would be to focus on hydrogen export for continental Europe. So it's really connected with the presentation of Efla, and maybe for mobility applications also. And so indeed in Iceland, there are some reports considering to export more than 170 terawatt hours per year, starting from 2050. And to give an idea of this energy, it represents more than 2 times the entire electricity consumption of a country such as Belgium. So this is huge, and indeed it is a really good opportunity for Europe. And David is performing the different environmental analysis to ensure that this is environmentally positive. And so, yeah, the technology is slightly different. It's an alkaline one. And the input power of the electrolyzer mode is 5 megawatts. So it's 1,000 times bigger than the fuel cell that we will install in Mortsel. But the idea is to prove that it's possible to have those small decentralized reversible fuel cell to balance the electricity grid. And I wanted to be shorter, so I hope it's not too long, but basically it was the last slide. So if you have any question.
Thank you, Lionel, for this nice overview. I think we can give Lionel a big virtual applause again. And thank you for this. So if there are any questions, please feel free to unmute yourself or write it into the chat. So if there are no questions, I might just comment, and we will have tomorrow, we'll go into the life cycle analysis of hydrogen export in tomorrow's lecture within the environmental impact assessment course. So you will get more insights into that later on. But again, this is actually a very exciting project because it links energy cooperatives, citizen corporations with hydrogen production, and I think it's a really it will play a key role in decarbonizing and changing the energy system. So I think it's a very exciting project. So if there are no questions, anyone with a question? I don't see any questions. I would like to move on to the next speaker, Sophie Lutz. She is the co-founder and director of ZuidtrAnt. And please, Sophie, the floor is yours.
Okay. Can you hear me and can you see the slides?
Yes, we can hear it and we can see your slides.
Thank you. First of all, I want to thank you for the opportunity and some background. I met David in October when I visited Iceland for the first time for the work meeting in the context of our H2 cope storage project. And I was really amazed of the natural resources in your country. For a little bit background for those who don't know Belgium and only Belgium who only know Belgium from the maps. We are a small country between France and Germany with a short coastline, a very flat country, and we heat our houses and buildings mostly with the natural gas from Russia and Norway. And about half of our electricity comes from old nuclear power plants that have to shut down around 2025 for safety reasons, because they are a little bit too old. The bills for electricity and heating for the citizens are rising very fast and very high. So that's a little bit of background of Belgium. And now I will start to present our two cooperatives, because we have not only one, but we have two cooperatives. And I will start with a little bit explanation about our name. ZuidtrAnt is very difficult to pronounce if you don't speak Dutch. It comes from the ZuidtrAnt, and it's the southern edge of the city of Antwerp in Dutch. And also you see the Trant, it's from the transition. It's also very important for us, the transition movement. And we also have the big A in our name, and it's the A from the city of Antwerp. So that's a little bit explanation about our name. And you see the Energy Cooperative ZuidtrAnt with a W behind it, and the W it's from warmte, and in Dutch it means heat. Who are we and why we started our cooperatives? So we are engaged citizens from the southern municipalities around the city of Antwerp, and we grow from the transition movements. So we really believe in the transition from the fossil fuel to the renewable energy. We want to have energy in our own hands, because like I said, the bills in Belgium are rising very fast, and we thought if we have it more in our own hands, we will have more control. We also want to have more impact on the acceleration towards a fossil-free society, and we wanted to accelerate also the investments in renewable energy in our country. So what's also very important, we wanted to create a win-win situation, win-win for people who invest in us, and a win for the companies or stakeholders who want to participate in our projects. So how do we create that? So the profits from our energy cooperative, they flow back to the local community, to the people who invest in us. We can also provide low-cost renewable energy, and that energy is independent of market fluctuations. So the building owners, where we put, for example, our solar panels, can take low-cost solar energy from our company. We started in April 2016 with 15 volunteers, and now in June 2021 we had 1.5 full-time equivalent in our company. So we started small with voluntarily engagement, and now we're making a little professional. We try to professionalize. How does it work? Energy cooperative, Lionel already told a little bit in the presentation of REScoop Europe. So the citizens, they invest with their own money, with their own capital in renewable energy projects from our company, from our corporation, and they do it in the form of shares. The profit of the energy projects in our company, they partly flow back to the local citizens. What is very important to know that the citizens who invest in us don't have to be citizens from our area. It can be everybody from Belgium, even everybody from Europe can invest in an energy cooperative. So that's also very important to have in your mind, that if you start a cooperative in a region, you don't have to have the investors of that region. You can have the investors of the whole country. Not only citizens can invest, but like Lionel said, also municipalities or other SMEs or other forms of companies can invest in an energy cooperative. What do we do with our energy cooperative? We place solar roofs, mostly on buildings of the municipalities in our region. We also try to motivate the electrical car sharing, and we try to fill the battery of the cars with our solar energy, and we do it with another cooperative, Partago. we assist energy renovations for private homes to look for less energy consumption in the households. And we also participate in innovative projects like the starting of energy communities and sharing energy. We also participate in the H2 coop storage project, and we developed our own bicycle storage, off-grid bicycle storage unit where the cargo bikes can be stored, and also the solar can fill up the battery. A few numbers. We today we have 630 members around the whole of Flanders. So it's not only our region, and we have 600,000 euros invested capital in our ZuidtrAnt cooperation. Like I said in the beginning, we have two cooperations, and the ZuidtrAnt with the W, it's the cooperation specially founded for renewable heating projects. In the picture you see in the right background, you see an industrial plant of Agfa-Gevaert. They produce different images. They produce different sorts of image technologies, and in the picture you can see the big chimney from long time ago, where the heat is going into the air. So in the production side, they have a very big industrial residual heat, and we are using that heat for new residential areas and SMEs. The new residential area that we are heating, you can see in the picture left in the left corner in the left corner down, you can see where the residential area will be built, and in the right corner down, you can see the SMEs where we are also giving the heat. This is a partnership between 3 like-minded companies, so we didn't do it ourselves. The investment of this project is an amount of 5.25 million euros. And we divided the investment is divided in the subsidy of the Flanders. We also have the bank loan, and the rest of the money we needed is from cooperative money from citizens. On the next slide, you can see pictures of the distribution unit, and that unit distributes the heat from a production process from the industrial plant to the heat network. The heat network also crosses 2 big traffic roads and an elevated green buffer, and we had to do some drillings, some pull drillings to pull the pipes in the right direction. The numbers from ZuidtrAnt are a little bit different. We have less members, but 300 members, but they invested more capital in our energy cooperative. So now I situated a little bit our 2 citizen cooperatives, and I wanted to close my presentation with a few recommendations or suggestions for Iceland. Like I said, I was amazed from the potential of your country, from the energy potential of your country. And in the near future, the shift towards renewables and the phasing out of fossil fuels will increase. It will increase also the importance of green hydrogen. Because Iceland has a big and great potential to produce the green hydrogen, as Hafsteinn mentioned in his presentation. The production of hydrogen can come from renewable energy sources, and that's why I wanted to suggest to let citizens enjoy the financial benefits of the renewable energy sources by letting them participate in the project. So what can the government of Iceland do? That's including a mandatory share of citizen participation in the development of new commercial projects for for example, wind farms. I really wanted to suggest that don't sell off your natural resources to foreign investors, and try to keep the money in your own country. So keep the resources in your own hands, and that's the way you can create prosperity in your own country, and you retain the control of your own natural resources. So that was the suggestion I had for Iceland. Maybe somebody want to, or somebody has some questions.
So thank you very much, Sophie, for this great presentation about the energy corporations in Belgium. I think we can give a big virtual applause to Sophie for her presentation. And so feel free to ask your question. In the meantime, I will already ask the last presenter, certainly last but not least, of course, Ulfert Höhne. He's the founder of a Austrian citizen cooperative. So just to give you another example of a citizen cooperative from Austria.
David, you said a question, but I want to, the last recommendation of Sophie on for Iceland is valid also for Africa, because I think this concept of energy cooperative is not so known in Africa, but I think these lectures at the end, just as you did yesterday, if you send me the YouTube, I think I will post it in Africa so people should get ideas about such things. It's something very, very necessary also in the global south. This concept of cooperative and ownership to fight the migration of youth from Africa to Europe. We have to create jobs. We have to create things where people can benefit from, and I think this idea is a wonderful thing. And the recommendation for Iceland is valid for Africa. That's what I want to say.
Yes, it's very right. It's for every country, and even the rich countries or more poor countries. You have to hold your the power of your own sources and do not sell it out to foreign countries. That's my opinion. So you can the citizens can benefit of their own country enrichdom.
Okay, thank you very much. Is there another short question for Sophie or comment on her presentation? Otherwise, we will proceed with the last presentation. Ulfert Höhne from Austria will present his citizen cooperation, energy cooperative.
Hello, thanks for having me. Best
Welcome.
Wishes from Vienna to Iceland and to everywhere in the world. Excuse me, I couldn't take part in your seminary the whole day, and I'm just briefly here. I've been asked to present to you the situation in Austria and our citizen cooperative, Our Power, which I will do. And I would like to share my screen to you and give you the presentation. And I ask you if you have any kind of questions you have. Wait, I'm jiggling around with my screen. Just interrupt, but first I have to start this thing. Wait a minute. Still not the right thing. I have to do it once more. Wait.
We could see for a short moment, we could see your slides. I think
Okay.
Just before we could see you.
But I can't move the slides. That's the point. Probably now it will work. Wait a minute. So you see my slides?
Perfect. Thank
But
you.
which one? You see the...
We see the title page. Now we see this next. Now you're switching the slides.
Wait. Somehow it's not what I... Sorry. I don't know what... So you have seen nearly everything by now?
Yes,
and you see the title page. Okay. Excuse me, please, for this
yes.
problem. So Our Power has been founded in Austria, and I tell you a little bit about the story, and probably also a little bit about the regulatory situation in Austria, if this is interesting for you. So first, who is Our Power? And second, the regulatory benefits. Our Power has been founded 3 years ago by 19 entrepreneurs, innovators, people in the energy business with long experience, and with the idea to really change the electricity market and bring power back to citizens, to the people. Today, we have more than 500 members. The slides are a little bit older. And we have got an office in Vienna and 2 regional offices in other parts of Austria. Austria is not as large, but the point is, it's really founded by high expertise. For example, I have been a long-term manager of a green power utility in Austria, a founder of this, it's a share company, and a couple of other peoples on this, you see on this picture, are in the renewable energy business, in solar PV system, in the small hydro business, and so on, as well as people from the with high experience in citizen participation in digital energies, and so on. The idea is the situation is we are in climate emergency state, and we have to change the energy and transform the energy business as fast as possible, and that will not happen without citizens being involved and activated as fast as possible. Probably you are aware of the European Clean Energy package, which in its, for instance, in the Electricity Market Directive, EMD, puts it in the really strong words. The vision and the target is to build an energy system with the citizens at its core, where citizens really take ownership of the energy transition and participate in all markets in the energy business possible actively. And by empowering consumers with a new regulation and provide them with new tools to participate and actually be in the driver's seat of the energy transition. And that's the point where our power drops in. The tools to participate have the need for new technical tools. And that's what our power does with the peer-to-peer marketplace, as well with political work we are doing. And of course, to activate people, we have to work together, build new PV systems, activate small hydropower stations, and prepare a lot of fun in being active in the energy transition. What our power build is a peer-to-peer marketplace where everybody can sell the electricity he himself produces, even the smallest generator who has some PV kilowatt hours as a surplus from his own rooftop can sell it to his neighbors and friends all over Austria. And this is a little bit about the wordplay. Mach deinen Strombezug zur Strombeziehung. So make your power purchase to a powerful relationship to people. And this is the way we put citizens in the core of our business model. Today, on the marketplace, ourpower.coop, since we are a cooperative, there are already more than 180 generators now in November selling their electricity produced to neighbors and friends directly via our peer-to-peer marketplace. And it works like every other power supplier does. You give in your zip code, your postal code, and your annual consumption, and you can choose out of this 170 generators, but then the marketplace gives you, there are some more to choose, gives you your, or prepares for you your personal offer. That is, you have got 3 or 4 different small generators, and you buy electricity exactly from these, and you get a quote for the sum you pay per month, including grid tariffs and taxes and everything. If you don't like this or like to change it, you can click on change the selection, and then you can change the shares, the percentage, or even change the power stations offered to you. And in the end, you click again and say, okay, I order now. And then you are part of this huge community. And on your invoice in the end of year, or if you have already a smart meter end of month, you get detailed list of where or how many kilowatt hours you get from your chosen hydropower station, chosen wind power station, and solar power station, and the rest, if you have more or less, if generators produce less than you need, or you consume more, you have a share from the Our Power pool, and you exactly know where the electricity comes from and where your money goes to. And all this is at the time being without any technical restriction. You don't need a new meter or any kind of technical installation, and not you don't need a smart meter. We are not against smart meters, but for selling or buying electricity via our power, you don't need the smart meter readings. So altogether, what our power does is, as a cooperative, develop and operate an innovative peer-to-peer marketplace. By the way, we got nominated for the Austrian State Prize 2021 for this innovation, which is a big thing. We are very proud. Our power gives citizens in this way more say over the power they sell. If they produce power, they sell it, and they have the authority over the price and their customers, and especially consumers know where the electricity comes from. Give producers and consumers a tool to cooperate directly, provide the infrastructure for new citizen engagement and communities, and provide especially new financing mechanisms and resources to build new capacities as private or community capacities, and sell it and finance it by selling the electricity over a long time. And so our power acts as a central driver for, let's call it, energy democracy. And that's exactly what the electricity directive and the clean energy package says. This is one example. There's a wind farm in the north of Austria, has been built 1999, 2 windmills, 660 kilowatt hours. And in 2020, they had to decide what to do. They had 15 years, they had a feed-in tariff, a regulated tariff. Then they had been in the electricity market, which at that time was a pure spot market price at around 3 cents. Today it's much higher, but at that time they had really to decide. With 3 cents per kilowatt hour, they couldn't even pay the bill of the technician to just look after the windmills, and they had to reinvest to get a new permission. And with our power, they decided, okay, we sell the electricity to the local people at a price of 6 cents, and then we can invest and survive. And this was the first really big impact our power had to save these windmills from being scrapped and secure the operation for at least 10 more years. And everybody was happy and is part of our cooperative. So of course, a lot of small scale PV systems are being built within our power. And this is a little bit of our political work. We got involved quite heavily into the discussion in 2020 on the new regulation, on the new electricity law, which opens up the market for energy communities as provided by the Energy Market Directive. And we're quite active. And in the end, the law was, I think, is now one of the most progressive all over Europe. I don't want to go into detail for the new legislation in Austria, but the point is, since October, it is open to found so-called energy communities, Energiegemeinschaften, from consumers and generators which are connected to the same local grid, and take them out of the balancing system, meaning the energy community is something like a 15-minute aggregation. Everybody has to have smart meters, aggregation of production and consumption, and they get reduced tariffs for the grid use, as well as reduction in taxes and levies, so that they save around 4 to 6 cents per kilowatt hours for all the electricity consumed within the community in each 15 minutes time interval. At the moment, all this is still in preparation. No really foundings of energy communities have been taking place, but thousands, or at least a couple of hundred energy communities are already in preparation. There are 3 types of energy communities in the Austrian law. Number 1 is the more or less collective generation. So everybody in within one building, multi-party building, can buy the electricity from the rooftop, for instance, without paying for grid and taxes. This is already in force since 2017. Until now, not really very successful, but with a new law, it will really take up speed. Local energy communities under the same local transformers, that means around 100 houses approximately, can be 50, can be 1,000, depends on the local situation. Or regional energy communities in a regional substation. They get different reductions of grid tariffs, but all save the taxes and levies. So have between, say, as I said, 4 or 3 to 6 cents per kilowatt hours and savings. So we look forward to have really a very active situation in Austria on energy communities. There's also a third situation with citizen energy communities. Unfortunately, they have until now no financial benefits, but a lot of bureaucracy. So this will not be, as it is today, extremely successful. I skip the next slide and point to one very important thing for the regulation in Austria. It's not only the regulation, but also we have got support beyond regulation by an official agency called Austrian Coordination Office for Energy Communities. They provide all the information and connect people and try to spur the formation of energy communities by mediating between grid operators and regional players, between incumbent utilities and new players, and work together with at the moment with the subsidization program to implement the first, or to subsidize the first around 200 or 300 energy communities. The situation first the conclusion on this regulation. 4 points. It's quite a complex model, but we have point 4, the coordination office as an agency to help through this complexity. A little difficulty is the strong situation and role of the DSO, of the grid operator, which is factually the incumbent in every region, which is quite a difficulty. But again, we have the agency which tries to mediate between these players and against the incumbents. And the most important hardship is it's defined only technically. That means the energy communities as proposed or as foreseen in the law are only defined by the grid situation where they are connected to. So you can only sell your electricity within this energy community, with this legal energy community, in your direct vicinity of the grid. And this is where our power comes into the play. Our power facilitates the cooperation between people which are not connected to the same local grid, and between energy communities which live in different grids, and provide the possibility to trade between legal energy communities, because our power, of course, is a big community as well, already more than 500 members, as I told. So as we see it, energy transition is not primarily a technical challenge. We have got all the technologies at hand, and we shouldn't put citizen engagement under the technological hierarchy, since energy transition is a question of cultural and social changes, and that's what our power tries as good as possible to promote. And of course, we have with this a lot of more fun to build together PV systems and even energy savings campaigns and so on, because the pure technical definition puts everything in this hierarchical situation that in the end the grid operators is the boss. And for the time being, it's okay, we can work with these bosses and change them, but the goal must be to have a really peer-to-peer energy environment, which is, we call it with the 4 Ds, decentralized, of course, digitalized. We have got this technology at hand. Decarbonized, yes, sure, that's the driver, because we are in climate emergency. And democratized, we need an energy democracy, because only if citizens and people are involved, we can change the culture of energy use and harvest all this tiny fractions of energy spoiled everywhere or overconsumed everywhere, and change our consumption patterns to the energy coming from renewable energy sources, since not all regions are rich in the way you in Iceland are. So let's have a lot of power and fun together. Thanks for listening.
Thank you very much, Ulfert Höhne, for your presentation. A big virtual applause to Ulfert for his presentation. And if there's any question, please feel free to ask Ulfert now. If there, I might jump in to ask a small question until
yes,
people
please
prepare the question. Of course, as an end user, we're always interested in the price per kilowatt hour for the end user, including taxes and grid use and everything. So you said 6 cents. That is what you're selling between if you sell the energy. What would be the price, including now the new law with the reduced price for the grid use? What do you estimate will be the price for the end user?
Thanks. Core question of everything. Thanks for this. First, our power as the peer-to-peer marketplace as it is at the moment. Excuse me, please. Our power is not a trader, but a trading platform. On our power marketplace, the generators fix their prices themselves. Most of them fixed it at last year's high level price of 7 cents per kilowatt hours, the pure energy price, and guaranteed this price for 7 years. So it's enormous price stability, because they our users on the marketplace are not mainly interested in maximizing their surplus, but just want to operate their systems economically. So at the time being, we are one of the, since European electricity market prices skyrocketed and are now at around 10 to 20 cents per kilowatt hour, just the spot market prices. So every incumbent and utilities is really rising their prices and doubling and tripling it, and our power is still stable. And at the moment we are really sold out, because all our generators sold all their electricity. But we're growing, and next month a new wind farm will join us. And I mean, joining us at the time being where spot market prices are really high, needs from system operator, or not system operators, on wind farm operators, a real long perspective. So that's the point. Our power is just a platform, and generators put their prices themselves. We help them, we moderate them to have fair and cooperative, as we are a cooperative, prices. On the other hand side, the other question is, what does the new electricity law bring, which allows for reduction of grid tariffs of up to 6 cents per kilowatt hours, because on the hour power marketplace, you sell it and you pay the normal, which is regulated, grid tariffs and taxes and so on. And now on the local level, we can of course also harvest these opportunities of reduced prices, and in this way lower our prices compared to the pure non-energy cooperative marketplace. So our power customers on the local level will even since they or even if they already have low prices at the moment, get more reductions on the grid level compared to the situation now. And we are just forming all this, or preparing the formation of all these local energy communities to reduce the prices. So altogether, on the overall price system, our power used to be last year more or less on the same level as other premium green electricity suppliers. But today, our power is one of the cheapest offers in the whole Austrian market. In the perspective to the future, we will be even more, even cheaper, since we harvest the possibilities of grid price reduction, tax reduction from energy communities, from the formal energy communities of the law.
Thank you very much. If there's no question from the audience, I would like to ask a follow-up question. Because as you know, with Lionel and Sophie, we have a project focusing on using the excess energy to produce hydrogen and make it available. And my question to you would be, what is your take on you know, the excess energy, and could our power make the energy for hydrogen production, for example? Could they provide it for a cheaper price if it's only used for the excess energy that this cannot be sold?
Wow, that would take another lesson. But of course, our power is working on possibilities to use the to go in the direction of storage, and that needs, for instance, hydrogen. But at the time being, in the Austrian market, in the whole market, we nearly don't have any excess energy. And in the community, even if it's a local community, you may have surplus energy, especially, for instance, in summer, if you have a lot of PV systems in your vicinity. But I doubt if it's cost effective to produce local electrolysers and stuff on a medium and smaller scale at the moment in Central Europe, especially since market prices for electricity are in the forecast at beyond 10 cents per kilowatt hours for the whole year of next year. So technically very interesting in the long-term perspective, meaning beyond 5 years from now. It's really necessary. We as Our Power are interested and discussing with possible partners, but in the next 2 or 3 years, it's not our business, because economically not sensible. But for instance, we are in close contact in Germany with Greenpeace Energy, which is now called Green Planet Energy, who are operating and who are also a cooperative. And I know the people from direct personal involvement, and operating 2 electrolysers in Germany already with a long-term perspective. Yeah. But you probably have surplus energy in Iceland, so we probably could talk about buying stored electricity in form of hydrogen from Iceland.
Yes, we had a talk just before you.
Okay.
Perhaps I can make it available on as a video, and you can
please
take a look into it.
Yeah.
So thank you very much again. It was really a nice insight into the energy market and into energy cooperation cooperates in Austria. If there's a question from the audience, please feel free to ask now, or to type your question into the chat of the Zoom meeting.
And since we are, as Our Power, a European cooperative, already with the idea, we have to be operable in many member states of the European Union and beyond. I can invite you to become member of Our Power Cooperative with 100 or more euro per share, and prepare the citizen energy future together with us. Thanks.
Okay, a direct statement to the audience that if anyone would like to invest in the energy corporate in Austria, they can go to ourpower.coop, C-O-O-P, and become a member of Our Power.
So how do we proceed to get a share?
Pardon? I didn't understand.
How can one proceed to be a shareholder? If I want to invest the 100 euro, what should I do? Should I contact you personally?
No, just go to our website on ourpower.coop. And unfortunately, only in German at the moment. And you have Mitglied werden, become a member, and you fill the thing out, and you become a member. Find everything on our website.
Okay, yeah. I can speak German, so I can do it. Okay.
Great, Daniel, we get into contact.
Okay.
Okay, I think this is a very nice closing point. I would like to thank again to all the invited speakers. A big applause to all the presenters. And I hope that we can continue the discussion, perhaps in joint projects, perhaps in joint energy corporations. And I look forward to continue the discussion at the cooperation in this sense. So thank you very much all for joining, and have a nice afternoon, and thank you again very much.